Okay, so now I've created my class there with 3 fields and 1 method. Okay, or with 3 instance variables and 1 method. Okay, so now I want to see now from there, after you have created a class, you can create an object of that class. So in that case, remember, like we said, a class is usually a template that you have created, or it's a blueprint. And now with the blueprint of the template, you can be able to create as many boxes as possible. For example, maybe I can have a box to store a phone. I can have a box to wrap around a fridge or any other gift. Okay, but all those boxes, there will be 3 characteristics which will always remain constant. Okay, so now I'm going to create I want to create an object inside my public static void main method. So I'm going to go here. So to create an object, we usually use the new keyword. Okay, so I'll have now box in my class, and then I'll have now maybe on box is equals to new box. So now I've created an object. I've created an object called phone box using the new keyword. Okay, so every time now we use the new keyword in Java, it's like we are saying now there is this box there is this class which doesn't have any memory. Okay, so the new keyword now creates some memory for our object here. Right, together. Now let's say, for example, and why do we need these brackets? Okay, I'm quite sure you are all aware of a concept of constructors. Okay, so I can have my class having a constructor. Okay, for example, let's say here, I can have a constructor here. The constructor is supposed to be the same name as the class, but it doesn't have a return type. Okay, it's just the name of the class. And then now I can say, maybe I have a parameterized constructor here. Takes 3 variables as well. Then I can have a length equals to L, width equals to W, and height is equals to H. Okay, so I have created my constructor there. Okay, so I've created a constructor here, and what a constructor is used to do, it's used to initialize. It's used to initialize instance variables when you create an object. Okay, so at this point now, this is where I'm creating an object. So these brackets, you are supposed to pass the constructor variables, or you're supposed to pass some values to the constructor. So in this case, initially I didn't have any parameters in my constructors, but since I have added 3 parameters in my constructor, that means when I'm creating my phone box, I must pass 3 parameters. So in this case, I'll pass 3, 4, and 5. Okay, so in this case now, I have created my object. After I've created my object, now I can be able to call any function of that object by using the dot notation. So in this case, let's say I say now I love, let me just declare another variable here. We'll call it int vol. Then here I can have vol is equal to one box dot volume. In this case, my volume here is supposed to take 3 parameters, but since it's a redundancy, I can remove these since I already have them. Since I already have them in my constructor, I can remove them in my volume. So that here I'll have return length times width times height. So in this case here, I will not need to pass anything into that volume since I've removed that particular those particular parameters. Now from here, maybe I can print out my volume now. We can have a system dot print line. Then I can have the volume is, then I use a plus to concatenate, and then I'll have vol. I'll have my semicolon here. Now there is supposed to be out here, system.out. Okay, and so now I have my program. Now, how do I run this activity now? So to run this activity, I just need to right click anywhere here. And so context menu will appear, and then you can select run Java basics.main, or you can run Java basics with coverage. So in this case, I'll choose, let me try run Java basics.main. There are some windows which will appear below here where my project is configuring. So in this case, it couldn't complete. So I'm going to run with coverage. Right click and then run Java basics.main with coverage. Still running. My Gradle build is running. Let's give it a few minutes and see what output it will give us. Okay, and you'll see my code has run, and down there it's indicating the volume is 60. Okay, hope you can be able to see that it's saying the volume is 60, which was computed from by multiplying 2 by 3 by 5. Okay, so that's how you run now some programs within Android Studio. Okay, for example, I could add maybe another method in my class box. I could add another method for area. Could have maybe int area. Okay, and in this case, maybe I could have I don't need the parameters there also. Then I return length and width as this one is supposed to multiply everything by 2. Plus length times height, then plus width times height. Or preferably, to avoid too much hassle with that, and I'm going to cut this. And I'll declare another variable inside here for volume. I'll have int, service area, int S area, and then I'll say I'll have S area is equals to that. Still have some errors, misstatements. Okay, let's just have a length times width. In the same way, I can be able now to call my area here from the name. I'll be able to come and say now system out print, and then I can have font box dot area. Okay. And now I can also be able to run that with coverage. Still running, so that you can see what it will give us. And it will give you some output of 12 here, though I used print instead of print line. That's why it appears on the same line with the next one. Okay, so you can be able to try out all the other features. Okay, yeah. So for example, I could even have another class here. We can inherit that one. Okay, so for example, let's say I add class small box extends box. Okay. So in this case, you are using the concept of inheritance. Okay, and I can have my constructor there, and then I can be able now to include extra methods inside my subclass here. Okay, so in this case, I'm trying to extend the class box. I hope we are together on that. Okay, well, I mean how now your application operates. For example, maybe in our case, if like, for example, I was creating an application for processing student marks. Okay, one thing that I check in the controller is if it's the cut marks, is it below 40? Okay, so that if now it's above 40, I'll know now that doesn't meet our business specifications. Okay, so now in this case, now you'll be able now to achieve that through writing Java code. Okay, yeah, and then maybe I can read this through. A model consists of the Java code and API objects used to represent the business platform and manage the behavior and data of the application. Okay, yeah, and then now the view is a set of screens. the user sees and interacts with. Then the controller now is implemented through the Android OS, responsible for interpretation of the user and system inputs. Okay, yeah. Input may come from a variety of sources such as a trackball, keyboard, touchscreen, GPS, and what have you. Okay, so now in terms of Android, we can be able now to see now what are the three different aspects. Okay, what we are saying now, the model is the one which represent business problem and manage now the behavior and data of the application. And in this case, we usually use Java code to create models. We use Java code and APIs. Okay. So, and an API basically, what an API stands for, it stands for Application Programming Interface. Okay, and an application programming interface is usually used to access or to provide a way for a client to access, to interact with a server. Okay, yeah. And then now the view is now the interfaces or the set of screens or the presentation of your application. And then now the controller is the one that now responsible for interpretation of user and system input. And then now getting ready to create MVC conforming solutions. Okay, these are the things that you should be aware of. One, you should be aware that input can come from different sources. Okay, yeah, the user can be typing in the inputs, or you can be reading them from a database. Okay, yeah, and you need to know now how do you handle those signals through what you call callback methods. Okay, and you'll be able to see what those callback methods are. Okay, then also you need to know how to move the different states in the life cycle. Yeah, so that is, you should be able to know the states like on pause, maybe on create, yeah, and the others. Then you also need to know that views are unlimited in terms of functionality. Okay, yeah, so that means the views can do a lot of things. Okay, but now the only thing you need to know is there are physical constraints. Okay, and physical constraints, and what we mean by a constraint, it's arrangement of components in relation to the others. For example, if I wanted to add a button on my interface, and then there is already a text view or there is already a text box, I need to specify now from where the text box is placed, where should the button appear. Okay, those are what you call constraints. You must show how now the components are arranged or the relationship between them in terms of now arrangement. Okay, so those are some of the things that you need to be aware of when you're creating the views. Then now we can concentrate now on the view or the user interfaces. Okay, and an Android user interface is similar to an HTML page. Okay, and this comes at the right moment now, since you have already understood some aspects of the HTML page. Okay, you know that HTML page, you'll find that most of your components or the tags are usually nested. Okay, for example, you can have a table tag, and inside the table tag, I'll have rows, and inside a table row, I'll have table data. Okay, so that is the same case. In a similar manner, that's how now your Android interfaces or user interfaces will be organized. Okay, yeah. So in this case, you have said, in a similar manner to a web interaction, when the Android user touches the screen, the controller interprets the input and determines what specific portion of the screen and gestures were involved. But now, the one difference now you'll find between an Android app and a web application is, for example, for any content on your web page to change, there is a likelihood that the address or the URL will reload. Okay, yeah. So for example, for me to go maybe to the profile, the web page will reload. All the data that is specified on the page means I must reload. For example, if maybe I was dealing with, if I was trying to check some posts on something we call a Medium, I was trying to view some stories on Medium. Okay, and then I have some new stories appearing, I'll have to click on, I'll have to maybe to refresh for me to see new stories that have been posted. But now in an Android application, that doesn't have to happen. Okay, there is some background which there's some code which runs on the background to make sure that the refreshing is done automatically. Okay, the refreshing is done automatically. So that's what you are saying, that unlike a web application which refreshes its page after an explicit request from the user, an asynchronous Android background service could quietly notify the controller about some common change of state. And this word asynchronous, you might see it quite often. And what asynchronous means, it's okay. Asynchronous is the opposite of synchronous. Okay, and what we mean by synchronizing is that, for example, if I have two copies of a file, I have one local file and I have another one on the cloud. Okay, so I could set it in such a way that anytime I make a change on my local file, the cloud one refreshes. Okay, but that's not what usually happens with Android applications. Okay, the Android applications, you will usually work with something we call promises. Okay, something called promises. Yes, I sent a request. Okay, and then now the server will promise, yes, I will send you. But that doesn't mean it's guaranteed. So it doesn't mean the way your app appears now is the way now your database is. Okay? Yeah, it's only a promise which might not be kept. Okay, yeah. So that's what you mean by asynchronous. Is where now, yes, I have another copy of this data that I'm showing to your interface, but it might not be the same at the same time. Okay, but I promise anytime I notice a change in the backend, I'll send those changes to you. So now we have the we have the view class. Okay. Yeah, and the view class is the Android most basic component from which now user interfaces can be created. And a view will occupy an area on the screen and is responsible for drawing and event handling. Okay. Then widgets are subclasses now of view, and they are used to create user interface components such as buttons, checkboxes, labels, text fields, and etc. Then we have layouts. Layouts are invisible, and layouts, you can think of them as containers. Okay, they are the containers where we will be placing or where we will be arranging our widgets. Okay, because remember now the widgets are the ones that the users will interact with. For example, the buttons. Okay, now for the buttons, I just don't drop them anywhere on my screen. Okay, I will need a container to contain those particular buttons or text fields or the different components. Okay, that container now is what we are calling a layout. So now when you are designing your user interfaces, the first thing you will need to decide is which layout do I use to arrange my components. So you'll place the layout on your view. Then now inside that layout, now you can be able to add the different widgets that you are intending to use in your application. So you can use XML to represent user interfaces. Okay, yeah, and this is how it will look. For example, you can see here we have a relative layout, and then it has some properties here. So these are properties of that particular layout. Then now inside them, the relative layout, you will find that here we have the opening tag for the relative layout, and also down here we might see where the relative layout is ending. Then inside here we can have now maybe an edit text box, we can have a button, we can have a text view, and so forth and so forth. Okay, so you can be able to type in, you can be able to create your interfaces using XML. Okay. Yeah. Then you have now nesting XML layouts. And as you can see here, like I was explaining, we have a linear layout here. Okay, the linear layout, this is like a tag. It starts with an anchor bracket and ends with a closing anchor bracket right here. Okay, the same case, this is an opening tag now. You have a closing tag down here. Okay, a closing tag in this case starts with an angle bracket, a forward slash, followed by the name of that particular now layout or widget. Okay, so remember, like if you remember very well when you are looking at HTML, we mentioned of something that we call the self-closing tags. Okay, so we can also have such a scenario here in Android Studio. In the case where now your widget or your view doesn't have any content, it will be self-closing. Okay, yeah, and most of them will be. Okay, so unless now you are nesting your layouts, then all your XML components will be self-closing unless there is a nesting. Okay, yeah, in this case you have a nesting here, and what we mean by nesting is where we have something inside another. Okay, that's what nesting is. And then now we can have setting views to work. Okay, for now your views to work, there are something that you need to set, and that's what you are calling now the settings. One you'll need to set is the properties. Okay, you must set the properties. For example, if you're working with a text view, you need to set the background color. You need to set what text will be displayed. You would also need to set what will be the font size or anything. Okay, you need to set the alignment. Where will it be aligned? Right, center, top, so forth. Okay. And then also you need to set up something you are calling listeners. Okay. And listeners are events. Okay, are events that this particular widget will listen for. For example, a button could have a click event. Okay, so we could create a listener for a click event. Okay, such that anytime the user clicks something, we perform something else. Okay, yeah. And then you have set focus. This one is used now to set focus on a specific view. Okay, and you need to call this method or use this particular HTML tag. And then now finally you have the visibility. Okay, you can hide or show a certain view depending on a certain condition. These are some sample layouts. This is linear layout. This may be a relative layout, table layout. So these are some sample widgets. Here you can be able to see a date widget here. You can be able to see a check button. You can be able to see a progress bar. We can be able to see a radio button. You can be able to see some buttons. Yeah, you can be able to see some different views. We can see a gallery view here. You can see a tab widget. You can have a spinner and what have you. Okay, those are some examples of widgets that you can have now in your application. You can have a map view is another widget that you can have in your application. You can have a web view. You can have a list view where you have a list of items. You can have an autocomplete view, an autocomplete text view, okay, which is a version of edit text box, which will provide autocomplete suggestions, especially when you want the user to search for some certain things. So now in your interfaces, like we had said at the beginning, or like we noticed at the beginning of this course, your interface will, when you are viewing it in Android Studio, it will be having two different views, actually three. You can have the XML version. You can also have the design version, or how the output is expected to look, and you can have maybe both of them side by side. You can see Brian typing. You want to ask a question? So what if you want to change a background color programmatically? You can do that. You can always use the dot notation. You can always use the dot notation to access any property of your widget in code. Okay. So for example, if I add a text view with an ID of name. Okay. Yeah. So I can specify it in code by having maybe r dot. Okay, you can find view by ID in code, and then now you assign it to an object variable. Then you can be able to access, for example, if I want to set the layout width, or I want to set the background color, I can have now. I can have maybe text view dot background color. Unless you are talking about maybe styling, special styling or anything, but I think Njero has already shown you that up here. Set background color. Use a set background color property, and then you pass now the color that you want to specify. So you have a number of layouts that you can use in Android Studio. You can have grid layout, you can have linear layout, you can have relative layout, you can have frame layout, you can have fragment, table layout, table row, and what have you. And the frame layout is the simplest type of GUI container. And this one allows you to define now how much of the screen is to be used. And all of its children are light to the left, and to the top left center. Then for linear layout, it can either be horizontal or vertically. So that means if you're using a linear layout, any widget that you will place it inside there, it will be, for example, you have chosen the horizontal view. That means the first widget, if it's placed here, then the next one will be placed against it to the right side. Okay. But now if I'm using the vertical view, they will be organized from top to down. Then you can have a configuring a linear layout. Can set some of these properties, okay, in a linear layout. The orientation can be set to horizontal for columns or vertical for rows. The linear layout can either be horizontal or vertical, depending on how you want the components to be arranged. Then the field model.
You are currently the only person in this conference.
So for the field model, all layouts or all widgets inside a linear layout must include the width and height attributes. In this case, you can see a specifying Android, full column, layout width, and you also have layout height. Then you can always specify the files in terms of DP, okay, that is device independent pixels. Okay, so in this case, we don't unlike maybe in HTML where you use pixels, okay, to specify certain dimensions. In this case, we use the DP unit, device independent pixels. You can be able to see that. Then we have this weight property, and what weight property does is it tells us now what ratio in terms of the components that are there will one component has. Okay, so if you specify as the weight as 0, that means that a particular component cannot be stretched. But now if you specify the weight as 1, it means the component can be stretched to fit or to occupy the remaining space. Okay, but now if you have two components and then one has a weight of 1 and the other one has a weight of 2, it means that one, if there is three spaces left, then the one with the weight of 1 will take one of the spaces, and then the one with 2 will take 2 of the spaces. Okay, so the higher the weight, the more the component of the widget is expected to stretch just to fill the remaining space. Then you have the graffiti, and the graffiti now is used to indicate how a control will align on the screen. So that one can be set to one of these. It can be set to left, right, center, top, bottom, center, horizontal, and all those. Then we have the padding, and the padding now specifies the internal margin in DP. And then the margin now specifies the external spacing, Then you have another type of layout you are calling relative layout, where the placement of a widget is based on its positional relationship. Okay, so for example, you can see here, A is the parent top. Then C is below A to its right. This one here, this is C here. And B is below A to the left of C. Okay, so it's just showing the relationship between the components. In that case, if you wanted such a layout, you can use the relative layout. Then now, when using relative positions, you need to use identifiers. Okay, so you need to have an ID property or an ID attribute on all of your elements. Okay, on all of your elements, and so you'll be using the ID property, and then now it should start like this. It should have this prefix. You'll have at plus ID / then you give it a name. Okay, e.g. this one you can have it at plus ID / txt username. Also, you should also have this prefix before the name so that you can be able to know now when you're referring to it in code, you can be able to know what type of a widget it is. Is it a text field?
You are currently the only person in this conference.
Hello. Then you have a scroll view, which can be either vertical or horizontal. And this one will be used in situations where you have more data to show than can fit in a single screen. In that case, now you'll use a scroll view. Okay? And the scroll view will provide some scroll bars. We provide either vertical or horizontal scroll bars to be able to achieve that. And in this case, you can see we have a scroll view here, which has a nested linear layout, and we have a number of text views inside there. Then there is now our horizontal scroll view. Okay, so you should always note that you have the vertical scroll view, and you can also have a horizontal one. In this case, for the horizontal scroll view, you can see here the element it starts with horizontal. Then now we have connecting layouts to code, but before you even go to connecting layouts to code, there is another layout that was came about recently, that is called the constraint layout. Okay, and then now the constraint layout is the one which allows you to easily create interfaces by drag and drop, and it's usually the default layout when you add an interface or when you add a layout in your on your code or in your code. It's usually the default layout, and in this case that one now allows you to easily create interfaces by drag and drop, dragging components from the palette and placing them where you want them to appear. And maybe we can, most probably, maybe we can try to look at an example of an application that can be how you can be able to go about now creating an application maybe that uses a constraint, that uses a constraint layout. And so in that case, maybe we can create a new application. So in this case, maybe I'm going to create a simple application from here. Just start a new Android Studio project. Then I select an empty activity. And then I can call it simple app. But remember this, the app name, you can always change it later. Then I select a language, Java. You select the SDK, and then you click on finish. Okay, so after clicking on finish, this is what you get. Yeah, you get one. There is one activity which has been created by you for you by default. That is the main activity. Okay, yeah. But if it has not been opened by default, you can click on App Java. not actually Java, resources. Then you have the layout and you have activity main.xml. Though I'm quite sure we went through this last time. Yeah, so you can be able to see here whatever is being displayed is a design. Okay, yeah, you click on these. Can click on this to change from design to blueprint. I think, like we noted earlier, one of the difference between the design and blueprint is the design will give you the final outlook of your application, but the blueprint will show you now how the layout appears. How the layout appears. So in this case, I'm going to delete. I just want I want to add just two buttons. For example, if I check, maybe I can check the code first, see how the code works so far. So you can see in my code, I only have a constraint, layout. Okay, so this is where now I want to now drop my components, my various components. But like I said, we did that last time. So since the layout is already there, I'm just going to add a text view. So I'll click on text. Okay, and then actually not text view, I'll add a plain text. Add a plain text here. Okay, but now when I add it, yes, I have added the widget, but that widget is not constrained. So to constrain it, I'll click. You can see these don't know whether let me try to zoom it in. Can be more visible. You can see these circles here, or these anchors. Okay, so I'm going to click on them and drag. I want to constrain it vertically. I'll drag this arrow until it snaps to the top. Okay, when it snaps to the top, now I can maybe move it down a little bit. Okay, and you'll see there is a constraint widget which appears on the right here. This is where we specify the constraints. So for example, you can see the constraint on top has been specified as 32 dp. Okay, so that is 32 from the top, but maybe I want it to change that. I would want to change that to 16. Also, on the right, on the left, it's not constrained, so I can add a left constraint here, okay, and give it also a 16. So that now means our component is horizontally and vertically constrained. Okay, that is, it shows where our component will be placed. Okay, yeah. Then now, in the same way, I can also add a button. Yeah. Just click and drop it here. But remember now that button I have added. Oh, Njero is saying he's not receiving any audio. Can someone hear me?